So in today's video, we're going to talk about the basics of plumbing design. So I'm going to be discussing main terms in plumbing, including waste, vent, cold water, and hot water recirculation piping. Then I'll explain the purpose of each of the items above. Then I'll discuss different types of plumbing valves and the purpose of each one. And they're basically going to be the main types of valves that you may encounter when designing a plumbing system. Then I will show the standard symbols and line types that are used for the plumbing items used in plumbing plans. So basically there'll be symbols for these different types of pipes that are mentioned here. For example, the waste, the cold water, hot water, and also some of the symbols that are used for the various different type of valves that can be used in plumbing systems. So we'll talk about plumbing definitions, and the plumbing definitions can be found in the 2022 New York City Plumbing Code, and this is the most recent code at the time of this recording. Chapter 2, which talks about definitions. And if you just go online, you search for New York City building codes, you should be able to find this link here. And if you go to the top, this is the latest version, 2022. They also have the previous versions of 2014, but you want to click on the latest one, which is 2022. And you click on this here, plumbing code. And here is chapter 2, definitions. So if you want to get the definitions for anything that's related to plumbing, you should be able to find it in this section. And here's the chapter 2. So I want to go over some of the more common definitions. One is the soil pipe, which is a pipe that conveys sewage containing fecal matter to the building drain or building sewer. So these would be, sewage that comes from basically toilets and, in other words, a water closet, which is another name for a toilet. Now you have waste pipe here, which is discharged from any fixture, appliance, area, or appurtenance that does not contain fecal matter. So this could be waste from a bathtub or a shower or a sink. Now you have waste pipe, which is a pipe that conveys only waste, right? Nothing else, such as rainwater. You have a vent system, which is a pipe or pipes installed to provide a flow of air to or from a drainage system, or to provide a circulation of air within such system to protect trap seals from siphonage and back pressure. I'll go over some of these terms later on. You have a vent stack, which is a vertical vent pipe installed primarily for the purpose of providing circulation of air to and from any part of the drainage system. And if you flip these words, it's a different meaning. So in this case, a stack vent is the extension of a soil or waste stack above the highest horizontal drain connected to the stack. So these actually mean different things if you reverse the words, right? The vent stack is the actual separate vent pipe all the way to the top, and a stack vent is just an extension of the soil or waste pipe. Hot water is water at a temperature greater than 110 degrees Fahrenheit, typically for domestic water systems or just any type of, a water to, let's say, a lavatory, a sink, would generally be around 110 to about 120. You don't want to go over 120 because that increases the chances of scalding and burning. So that's the reason why the maximum temperature is typically limited to 110 or 120. You have demand recirculation water system, which is water distribution system where one or more pumps prime to service hot water piping with heated water upon a demand for hot water. Then you have a trap, which is a fitting or device that provides a liquid seal to prevent the emission of sewer gases without materially affecting the flow of sewage or wastewater through the trap. Okay, on the left here is a basic diagram of a plumbing system. This here is the soil stack here. And everything is connected to the soil stack. As you can see, the water closet here This is the shower, and this is a lavatory, as well as this kitchen sink here. If you look up here, this is the stack vent, which is just the extension piece from the soil to the outdoors. And so this piece here is the stack vent, where all the other vents are connected to, as you can see here. And even the fixtures from the floor below are directly connected basically back to that stack vent here. Now, a soil pipe is the pipe that contains fecal matter, which is basically matter from a water closet, which is here. And if it contains waste piping from other fixtures, such as a shower or a sink, that pipe is called a waste pipe. Now, if it combines soil plus waste, they seem to mention that it's a soil stack rather than a waste stack. So if you look back at the definition, so here it's waste pipe is defined as a pipe that conveys only waste, and a soil pipe is a pipe that conveys sewage containing fecal matter. So it seems to also imply that it could contain other matter such as waste. But generally, when people talk about waste piping, they also mean soil. So, these two terms are used pretty much interchangeably, where most people use the term waste pipe. So basically, you might hear soil pipe being referred to as waste piping. And reading through this section, first they talk about required vent extension. The vent system serving each building drain shall have not less than one vent pipe that extends to the outdoors. So if you have multiple, groups such as this, throughout the building, you need at least one of these extensions through the roof. The other ones may not require this extension. Now, the vent shall be a dry vent that connects to the building drain or extension of the drain. The building drain is basically this drain down here. That's at the lowest point of the building. The required vent shall be sized in accordance with section 906.2 based on required size of the building drain. So if you go to the plumbing code, section 906 would be right here under vents. And 906 basically gives you this table here where it talks about depending on the drainage fixture units, which there's a chart that gives you these drainage fixture units based on the fixture type. So when you total that up, it basically gives you a maximum developed length of vent piping that is allowed based on the size of that vent here. So that's how you size vent piping. In this video, I'm not going to talk about the designing and sizing of the pipes. I just want to mention that they exist for now in this video. Vent stack required. A vent stack shall be required for every drainage stack that has 3 branch intervals or more. So in this case, this is considered a branch interval. Basically, one floor can be considered a branch interval. Most of the time, that is the case. So in this case, we have 2 branch intervals, right? And in that case, we do not need a vent stack, since it is only required for every drainage stack that has 3 intervals or more. Next, vent termination. The vent stacks or stack vents shall terminate outdoors above the roof or to the stack vent portion of the soil or waste stack at least 6 inches above the flood level of the highest fixture connection discharging into the soil or waste stack. So what this means about the flood level is, if you see this, for this example, this lavatory, the flood level is the level at which any flooding that happens would reach up to a maximum point. So the flood level is, in this case, at the top of this sink. So where you connect the vent for this one into the stack vent, that vertical distance here has to be at least 6 inches. So that's what that means. Vent connection at base. Vent stacks shall connect to the base of the building of the drainage stack. The vent stack shall connect at or below the lowest horizontal branch. Where the vent stack connects to the building drain, the connection shall be located downstream of the drainage stack and within a distance of 10 times the diameter of the drainage stack. So that means if the vent stack, okay, is connected to the building drain down here, it has to be connected, somewhere around here and go straight up to the building and maybe combine here to the waste pipe and go straight through the roof here. And the distance here is listed as 10 times the diameter of the drainage stack. And it has to be located downstream. So downstream in this case means down in the direction of the water flow. So this distance right here. And let's say the soil stack is 4 inches. It just means that it has to connect within a distance of 10 times that, so within 40 inches. Next, vent headers. Stack vents and vent stacks connected into a common vent header at the top of the stack and extending to the open air above the roof at one point shall be sized in accordance with the requirements of 906.1. And 906.1 is here, but shall not be smaller than the smallest stack vent. The number of fixture units shall be the sum of all fixture units on all stacks connected thereto, and the developed length shall be the longest vent length from the intersection at the base of the most distant stack to the vent terminal in the open air as a direct extension of one stack. So in order to size these vent headers, which is just the stack vent and vent stack, you would read this section right here, this table 906.1, which specifically states these are the sizes for the stack vent and vent stacks. Now, if you want to look towards the bottom for common vents and individual vents, they are in different tables. So if you look down here, this table here would just be for sump vents, which are just sump pumps. So this table is a little bit different. And also, if you look here, there's other tables such as maximum distance of fixture trap from the vent. So that means that, if you have a vent here, the maximum distance from this vent to the trap, which is this distance here, there is a table for that as well. And looking down here, there's a table for the common vent sizes. So if you have a common vent, which is multiple different fixtures basically using the same vent. And you also have something called a wet vent, which basically means that a waste pipe also serves as the vent for another fixture. So they're calling it a wet vent in this case. So there's another table to size those type of vents. And if you look down here, you have size of combination waste and vent piping, as well as if you keep going down, now you have an individual fixture header vents for smooth pipes. So there's another table for that. So as you can see, there's different tables for different type of vents. So not all vents would be using the same table. So you have to know how to differentiate which vent you're looking to size and make sure you're using the correct table to size that vent. So here it mentions substack connections, where it's desired to terminate stacks at a point below the roof terminus of the main vent stack. The substack may connect to the main vent stack, provided the portion of the main vent stack above the connection is sized for the total fixture unit load connected thereto, and and it continues here, right? Connected to and for the maximum developed length of the stack or substack. So what that means is that if you have a vent stack, which is not shown here, let's say you have a vent stack that comes from here, this bottom point, all the way to the top, and you decide to combine it in here, and you have multiple other vents that are connecting from other places of the building. So what it says here is where it is desired to terminate the stack at a point below the roof terminus of the main vent stack. The substack, which would be representing these substacks to the main stack. The substack may connect to the main vent stack provided the portion of the main vent stack above the connection, which is above this connection here, right? This is where everything is connecting to. So the main vent stack above that connection has to be sized for the total fixture unit load connected thereto and for the maximum developed length of the stack or substack. So that means that when you size it, you basically have to use this table here to size that portion for the total drainage fixture units that are being served by that stack vent or vent stack. Which is the combination of all the substacks as well as the main stack that is connected to that common vent. So to further explain the branch interval that was discussed before, the definition in the plumbing code, it defines the branch interval as a vertical measurement of distance 8 feet or more in developable length between the connections of horizontal branches to a building to a drainage stack. Measurements are taken down the stack from the highest horizontal branch connection. So in this diagram, you could see that this is the connection of horizontal branches. So there's one horizontal branch connection here, another horizontal branch connection here and here. And the distance between those two has to be 8 feet or more. So this case here, this is not a branch interval, but this case is a branch interval because it is 8 feet or more. So generally, every floor you could consider it a branch interval. And here's another diagram of what a branch interval is, and you could see basically each floor it goes down, you could consider it as one branch interval. So from here to here it will be one branch interval. From here to here it will be another branch interval, as well as all the other floors. So let's say that, for example, this distance here was 20 feet and you had a funnel drain that was somewhere in the middle of this floor. And let's say, the distance from here to here was 10 feet. And then this distance here would then be the difference between the 20 and the 10. So it would be another 10 feet. So in this case, I think, so in this case, based on the definition, this floor to this floor, you would have two branch intervals, right? One would be going to this, and the other one would be going to this drain here. So this is just a further explanation of what a branch interval is. Now I want to show you a diagram of a vent stack. So it's this right here. So this is the vent stack. It's connected to the base of this waste pipe here, this waste stack right here. So when we talked about the vent stack, we mentioned a case where it connects to the building drain. And if it connects to the building drain, it has to be 10 times the diameter of the waste stack. And if the waste stack is 4 inches, basically this distance here has to be 40 inches. So it has to be connected within that distance downstream of the connection of the waste stack to the building drain. And in this case, it's connected a little bit differently, and it's because if you go back to that section, it was this section here. It talks about vent stacks shall connect to the base of the drainage stack. The vent stack shall connect at or below the lowest horizontal branch. Where the vent stack connects to the building drain, it shall be located downstream of the drainage stack and with a distance of 10 times the diameter of the drainage stack. So it gives you two options, connected to the building drain, or the vent stack shall connect at or below the lowest horizontal branch. So where it says that this is the lowest horizontal branch and the vent stack has to connect at or below it, so in this case it's below it. So this is another way the vent stack can be connected, either to the stack or it can be connected to the building drain. Okay, now that we talked about the vent, we're going to go on to talking about waste piping. So the first type of waste piping, we'll talk about the building drain. And we kind of briefly talked about this before. Now, the definition is that part of the lowest piping of a drainage system that receives the discharge from soil, waste, and other drainage pipes inside and that extend 5 feet in developed length of pipe beyond the exterior walls of the building and conveys the drainage to the building sewer. And we'll talk about combined, which is a building drain that conveys both sewage and stormwater or other drainage. Storm basically just means rainwater. Then you could have a sanitary drain, which is a building drain that conveys sewage only. And then you could have a storm, which just conveys stormwater. Now, sewer, there's a few definitions for that in the plumbing code. And the first one is building sewer. That part of the drainage system that extends from the end of the building drain and conveys the discharge to a public sewer, private sewer, individual sewage disposal system, or other point of disposal. Combined sewer is sewer receiving a combination of sewage, stormwater, groundwater, and non-potable clear water waste. The private sewer, which is basically just a sewer system that is not part of the city, it's their own private sewage system. I generally don't design anything dealing with this. This is kind of less common in New York City. Next is the public sewer, a sewer that is owned by the city of New York. This is generally the type of sewer system that most buildings connect to, if not all of them, in New York City. Then you have a sanitary sewer, which is a sewer that conveys only sewage, and storm sewer, which is basically a sewer that contains only stormwater. So these are pretty much the same thing, except that it differentiates between a building drain and a building sewer. So here's the sanitary riser diagram, and I'm showing this diagram to demonstrate what a building drain is and what a building sewer would be. So the building drain would be this part of the piping, this part of the waste piping here, that actually also extends out 5 feet from the exterior wall of the building. And then after the 5 feet out of the exterior building, this here would be considered the building sewer. So anything on this side is the building sewer, anything on this side that is part of this lowest horizontal waste piping would be considered the building drain. So the P-trap is the piece that typically goes right below a fixture, and it looks something like this and like this. And the purpose is to seal the sewer gases from entering the occupied space. So if you have any type of sewer gases like this, it basically stops it from going into the occupied space here. And that's the purpose of the seal. And the trap seal is the distance of water from the weir to the dip. The weir is this part, and the upper part of the dip is here, and this here would be the trap seal. So the amount of water that has to evaporate before the sewer gases can actually come back into the occupied space. And there is also a maximum distance that the fixture trap can be from the vent. So the maximum distance from here to the vent, this distance here, the maximum is given by this table here. So for example, if you have a 2-inch trap and the slope of the waste is 1/4 inch per foot, the maximum distance from the P-trap to the vent can be 8 feet. So the purpose of a vent on the P-trap is that it prevents siphonage. And siphonage, you can kind of look here. And siphonage is, let's say you have a bucket of water here, and it looks like this. You have a tube that goes this way. Once the water fills the tube, let's say somehow we get the water to fill this tube here, and the water is now below this point. This water will now completely drain out, through this tubing from the bucket of water here, and that's basically through siphonage. As long as the tube is also extended all the way down to the bottom of this bucket. And siphonage, if you want to look at the formulas for it and basically how it works based on the pressure and the height, you could kind of read this section here. But I'm not going to go into that, the theories in this video. So let's say, going back to this diagram, if you didn't have this vent, what could potentially happen is if this sink was being used and the water fills up and somehow the water happens to fill up all of this and the vent was not here, the trap seal here could actually get sucked out through siphonage and you wouldn't have a seal anymore. So to prevent the trap seal from siphoning out, you basically add the vent, and that is one of the purposes of the vent.